Assalamu alaikum children. How are you all? Hope you all are very fine and fit, healthy at your home. Children, in last session you learnt about rotatory motion, but in today's session you are going to learn about oscillatory motion. Let us see what is oscillatory motion. Now, by observing these pictures, I will ask you some questions. What similarity do you find in the motions of these pictures? Are the objects in motion following the same path again and again? And what is the direction of motion? No, sorry. Is the direction of motion constant? And these pictures answers for these questions we will find after the discussion of this oscillatory motion. Now, if we critically examine these pictures, we understand that in each case the objects move backwards and forwards, or upward and downward, or on either side of the a fixed point or a line. For example, the girl on a swing moves backwards and forwards on either side of the rest position of the swing. Similarly, in other cases also, the body is in to and fro motion along the same path of motion. This type of motion is called as oscillatory motion. Now, when you come to this question, what similarity do you find in the motion of these objects? What is the similarity here? They are moving about a fixed point. And are the objects in motion following the same path again and again? Yes, they are following the same path again and again. Is the direction of motion constant? Yes. Now, we see the definition of this oscillatory motion. The to and fro motion of an object about a fixed point, always following the same paths, is called as oscillatory motion. Now, let us identify oscillatory motion among the following examples. Now, here you can see a spinning top. When you come to this spinning top, is it in oscillatory motion? No. What you can say about this? You already learnt about this. Spinning top is in rotatory motion. Now let us see next picture. A bullet fired from a gun. Now does the bullet from a gun is possessing oscillatory motion? No, not at all. It is not in oscillatory motion, but we can say that the bullet is moving in translatory motion as it is moving in a straight path. Next example, typewriter key. If you see this typewriter key, when we press a particular key, it moves downwards and upwards. As it is moving downwards and upwards, it has a fixed point. We can say that it is in oscillatory motion. Next example we see motion of a potter's wheel. You have already learned this in rotatory motion. It is an example of rotatory motion. Now next example, motion of a vibrating sitar string. If you see this motion of a vibrating sitar string, as it is moving side to side, we can say that it is in oscillatory motion. Next picture, a bouncing ball. A bouncing ball, it exhibits oscillatory motion. Next, ringing of a bell. It is in oscillatory motion. Another example we see motion of a car taking a turn while it is moving. Motion of a car taking a turn. As this car is taking a turn and is moving in a curved path, we can say that this is not in oscillatory motion but it is in curvilinear translatory motion. Now children, let us see about slow and fast motion. We observe many objects in motion in our daily life. In some cases, objects move slowly and in other cases, they move fast. How do we know whether the motion is slow or fast? Who reaches? Now, let us see with an example. Let us assume that you started to school on a bicycle and your friend started in a bus at the same time from a place. Who reaches the school first? You are your friend. Your friend reaches school first. Do you find any difference in the time taken by bicycle and bus to reach the school? Yes, there is a difference. Next we see. Next we learn about the comparison of motion of objects. Now we are seeing here a pair of objects. Among these objects, we see which one is slow and which is moving fast. When we compare an aeroplane and a train, which is slow and which is fast, you know that aeroplane is fast and train is slow. Next, we compare a bus and a auto. If you compare a bus and auto is slow and whereas bus moves fast. When you compare a cycle and a scooter, bicycle is slow and a scooter is fast. Next we see elephant and cheetah. Elephant is slow but cheetah runs fast. Next, a buffalo and a dog. When you compare buffalo and dog is fast when compared to buffalo. So buffalo is slow. Next, a man and a horse. When we compare man and a horse, man is slow. You know horse is fast. Do we need to know about distance covered, time taken by the body in motion to decide whether the motion is slow or fast? Let us look with an example. Let us look at details of a running race. Priya, Karthik, Divya and Kiran participated in a 100-meter running race. They took 20 seconds, 22 seconds, 25 seconds and 28 seconds respectively to reach the finishing line. What do you no? Who do you think ran the fastest and whose running is slowest? Why? Now I see. Obviously, we can see that all of them ran the same distance of 100 meter, but time taken to cover the distance was different. Priya took the shortest time of 20 seconds, which shows that she was the fastest. Next, Kiran took long time, that is 28 seconds. So who won the race? It's Priya. Now children, in next session we are going to learn about time. So children, up to that, study well, be happy. Allah Hafiz.